Hi guys, in this video we're going to go over the different types of functions that we will see in Math 3. Some of them should be very familiar to you, like linear. Linear function is when the degree is 1, which means it usually looks like y equals mx plus b. So linear function you should be able to identify pretty easily from the graph. The domain and range we're going to go over, but we're going to spend several days talking about domain and range and some of these other key features. For right now, your goal is to be able to identify what the name of the function is. But the domain of linear, anytime your function goes all the way to the left and all the way to the right forever, the domain is negative infinity to positive infinity. A symbol that we can use instead of writing that is this fancy R, which means all real numbers. All right, so domain goes from left to right. The range goes from the bottom to the top. So if you have an arrow pointing down and an arrow pointing up, then your range is also negative infinity to positive infinity. Or again, I'm just going to use that fancy R just because it's quicker to write. All right, so some other features of a linear function. Like I said, usually the equation will look like y equals mx plus b. And if you remember, m is the slope. So if your line is going up, like the one that I drew, then your slope is positive. If your line is going down, then your slope is negative. That's really about it for linear functions. All right, quadratic. You can recognize a quadratic equation because it will have x squared, or x to a second power. So the parent function for quadratic usually looks like that, like a U shape. The name of that graph is called a parabola. So if you see the word parabola, that goes with the quadratic function. And if you notice again, arrow to the left, arrow to the right, so the domain is all real numbers. Now there's no arrow pointing down for quadratic, and that's because of this point right here called the vertex. The vertex is either a maximum or a minimum. In this case, it's a minimum. So a quadratic will have a max or a minimum, and whatever the y value of that point is how we write the range. So the y value of this point would be 0, and that's the bottom of the graph. Range always goes from the bottom to the top. So for the range, it is 0 is the lowest value on the graph, but there are arrows pointing up, so it's 0 to infinity. All right, cubic has x to the power of 3. You can recognize cubic by this kind of wavy shape. It can get a lot more wavy than that, but it should, like maybe the most wavy that it's going to get. I mean, it could also look like that. And again, arrow to the left, arrow to the right. So the domain is all real numbers. Arrow pointing down, arrow pointing up. So the range is also all real numbers. All right, quartic is x to the power of 4 is the highest exponent. Now, the parent function for quartic looks exactly like quadratic. So I'm going to make this one look a little bit different so that you can tell similar to the shape of quadratic, but a quartic will typically have like a little maximum or something in the middle. I mean, it could also look a little bit like this, or just kind of like that. So you can identify it because it's the same kind of U shape, but it's not a perfect U like quadratic is. All right, same thing, arrow to the left, arrow to the right. So the domain is all real numbers. And again, this one doesn't have a vertex necessarily. The vertex is usually on a line of symmetry when it's a minimum or a maximum. But there are For this particular graph, there are minimum points. So whatever the y value, now if it was like this, where one of them was lower than the other, you would need to pick whichever one is the lowest. Your range is whatever the lowest y number of the graph is. So for this, it would be 0 to infinity as well, because 0 is the lowest, but there's arrows pointing up. All right, absolute value you can recognize because it will be in those bars. Absolute value makes the shape of a V, just like the word value. So again, domain, arrow to the left, arrow to the right. Domain is all real numbers. There is also a vertex for this graph. That is the minimum. So there will be a vertex that has a min or a max. And actually we'll put that for quartic too. Quartic will have a min or a max, a minimum or a maximum that you'll need for the range. So same thing, the y value of this point is 0. So the range for this is 0 to infinity. All right, and again, guys, we're going to spend several days talking about domain and range and some of these other key features. We're just organizing this for the time being so that we can use this to help us throughout the week. All right, exponential. Exponential has a key feature that none of the other ones have had just yet. Exponential functions have a horizontal asymptote. And on the parent function, it's at 0, 0. So that is a horizontal asymptote. And that is going to restrict how far down the graph goes. So an exponential graph is going to look flat up against that horizontal asymptote, but then it will curve. In this case, my parent function is going to curve up. So that's how you can recognize an exponential function. And if you look at the equation, your base should be a number. It doesn't have to be 2, but if you notice I have x as the exponent. All right, domain, all real numbers, arrow to the left, arrow to the right. The range is going to be a little bit different because the horizontal asymptote is restricting this. So whatever that y value is along that line, in this case it's 0. And I do have an arrow pointing up for infinity. But this 0 is actually going to get a parenthesis because that horizontal asymptote doesn't actually have any points that are on the function. So that function is approaching the horizontal asymptote, but it's never going to actually come in contact with the horizontal asymptote. So we use a parenthesis whenever it's like super, super close, but it's not going to touch. There's not like a vertex or a minimum point there. That's when we use a bracket, when it's an actual point. All right, rational also has a horizontal asymptote. But actually, most rational functions, like the parent function, also have a vertical asymptote. All right, and then the parent function for this, I need to switch my markers because my purple one is dying. Looks like this. So kind of straight up, and then it curves towards the other asymptote, kind of straight, and then curves. So the graph curves to meet those asymptotes, but it never actually touches it. So when you're writing the domain and range, because there's a gap in this, there's a number wherever your vertical asymptote and your horizontal asymptote are, we don't include those values. So we're not going to really focus on these for right now, but I'm just going to tell you that the domain for this would be all real numbers except when x is 0, because this vertical asymptote is the line x equals 0. And the range, same thing, would be all real numbers, but y is not equal to 0. And that's because this horizontal asymptote is the line y equals 0. Again, that's just something for now, write it down. We have like a whole unit where we're going to talk about rational functions. So you have plenty of time for that to sink in and make sense. All right, a square root function, also called a radical function, will have the square root sign. A square root function, the parent function starts at the origin and then kind of curves up. So we call this the initial point. And in this case, it is also a minimum of the graph. So the initial point will be a minimum or a maximum, depending on how we flip the graph around. All right, so the domain is actually not going to be negative infinity to positive infinity because I don't have an arrow to the left. This is the point 0, 0, and so the x is goes with the domain, the y goes with the range. So the domain, this point is the furthest to the left, and that x is 0. A bracket because that's an actual point there, and it does go forever and ever to the right. All right, and then the range is going to be the same because that point is the minimum. The y number for that point is 0. There's an actual point there, so it gets a bracket, and then the arrow is going to curve up. All right, piecewise, we're not going to talk about the domain and range quite yet of piecewise functions. You're going to recognize it because you're literally going to have multiple equations, but it's going to be with like this squiggly bracket here, and you see there's only one f of x, or you could also put y in the place of f of x. Those mean the same thing. So they're grouped together. So this is not exactly what this equation is going to look like, but it would look something like this. I'm just making this up. But you see how the graph is actually in pieces. All right, and then trig, oh, that's not supposed to say that. I'll fix this on the one that you guys have. The trig that we're going to mostly be using is sine and cosine. So if you see sine or cosine, these are going to be, they're called periodic functions, but it's going to look like a wavelength pattern. So it's a little bit different than like the cubic and the quartic. This would be that same wavelength pattern forever and ever and ever. So the domain is all real numbers because this will go to the left and the right forever and ever and ever. But the range, these arrows are not going to go up or down ever. We're just going to continue to make that wave pattern. So there is going to be a maximum and a minimum to the sine and the cosine graphs. So for this one, I mean, I just made this, my minimum happens to look like I put it at -1, and my maximum looks like I put it at 2, but on a real parent function, it would go between -1 and +1. But because this is the way I made my graph look, but whatever the minimum y value was to the maximum y value. All right, so these are all the types of functions that we're gonna study this year. Again, for right now, your goal is simply to be able to match a graph or an equation and tell me what type of function it is.